Fantastic. All right, so my name is Yunan. I'm a senior Node.js engineer at Netflix. Have you guys heard of Netflix? Our core competency is shipping you DVDs through the mail. So just so you guys know, we ship them by USPS through the mail to get you DVDs. Using Node.js, there you go, exactly. So I'm here today to talk to you about building observable applications within Node.js, and this is something that we use quite a bit internally at Netflix. And we wanted to share some of the tidbits that we've learned. So who here builds applications or services in Node? Hands up. Sweet, that's almost everybody, fantastic. So a little bit of a background about where we use Node at Netflix. So the website is on Node.js, so all the features including anywhere from discovering your content to playback, to acquisition, and to account management, that's all on Node. We also have a ton of internal services on Node as well. So internal teams will build their UIs and their applications on Node. And we're in the process of moving our TV or mobile and our devices UIs as well to Node as well. So it's a great journey for us. And of course, it's always a lot of fun, when you're building a new technology, right? Building on new technology, you're getting to play with new things, you're coding, life is great, right? It's fantastic. And then comes the day you actually have to run these services in production, right? I said the keyword, I said it, production, right? So what does that mean? Well, you see graphs like these in prod, right? These are pathologies that we've seen in prod, right? All of them are real life graphs that we have in prod that exhibit some sort of pathology. Anyone want to guess at what any of these three represent? Throw your guesses out there. The third one is kind of, there's like the y-axis has memory on it, but no one wants to guess? No. That's a good guess, actually, so we'll get to that. So the first one is increased errors, right? So I've shown you the legends now, so that's 200 or 300 errors that we're returning back to the client. Terrible, right? Second one is the Node.js in Flames. This is increased latency, so you see the drops there, and that's when we have these rolling reboots every 2 hours. That was fantastic. Let me tell you, that was fantastic. So you see our request latencies go up slowly but surely, the same requests, and they drop. And the third one we just had a couple weeks ago, which is a memory leak. So on the right, you see the last week's build, steadying around 250 megs. On the right, you've got that lovely curve, right? Up and to the right. Fantastic. So you see these, what now, right? What do you do, right? So one tenet that I always like to use is sort of this quote from Sherlock Holmes, and I'll just read it, where it's a capital mistake to theorize before one has data. So ostensibly one begins to twist facts to suit theories, and instead of theories to suit facts. And I've sort of bolded data there, right? Oh, you guys can't see this. Can you see this? There's a picture of Lieutenant Commander Data in a cowboy hat. For those of you who can't see, that's unfortunate. I worked hard on this slide. So data is really important, right? Without data, you actually don't know what's causing any of these pathologies. You can only guess, and in my experience, guessing usually makes things worse because you start fiddling around with all your different knobs, and software is super complicated, and you might make things worse. Or you might think you fixed something, and really you actually just pasted over a different problem, and then later on, a pathology will exhibit itself again, usually. In production, 3 a.m. in the morning, you get paged. Fantastic, right? So, to this end, you want to be able to look inside your applications and see what's going on, and this is actually really easy in your development environment, right? You've got debuggers, you can change your code whenever you want, you can put in printfs, you can hit it with the same request over and over again. It's generally pretty easy to look at your application state in development, but all of those pathologies that I showed you, we never hit in development. So I never got them on my Mac, I never had these problems. When we deployed the prod, and we're taking thousands of RPS per second, that's when we hit those problems. So what you really want is to be able to see all those metrics about your applications in production, right? That's what you want. So you want that extra into your production process. So what I want to talk to you today about mainly is a set of modules that we've been using and that we've been leveraging very heavily that really gives us visibility into our production applications. Does anyone know what this is? Or has anyone seen this kind of anti-pattern? Alex is laughing over there, but right. So this is like the first anti-pattern you hit when you're a JavaScript programmer, right? You're still wet behind the ears, and you go to your mentor, and he's like, okay, why don't you take the day off? Go learn about some other ways to deal with callbacks and come back tomorrow, right? So who's used async? Anyone uses async? Fantastic. So we used to use async as well, and it's got this pattern, right? I can string together an array of functions, and in this case, it runs them serially. I don't have callback L, and at the end, I have a callback to tell me, hey, everything's done. Astute readers, though, will see that this isn't actually async. It's a different module called vasync. And what's different about vasync is it's similar to async. There's a push to the GitHub page, but it adds observability. Again, I'm going to keep going back to observability all night, because that's really critical to this talk. It gives you observability into your asynchronous operations. So what's key is async gives you this results object whenever you invoke it and at the end of the callback. And this results object gives you the state of your asynchronous applications. So the first thing is you get operations, and inside operations you get an array with all of your functions that's inside your asynchronous pipeline, right? So I've got 3 functions here. I get the status. You can see that the first one has failed. You get the fail and the error there. The second one has run successfully, so I get status is okay. And I see my third function is still pending, which means it's been invoked, but it hasn't returned the callback yet. As well, you can see that the number of functions that are done by end done there is 2. So that tells me 2 functions are finished. And of course, one of them returned an error, so I get a number of errors equals 1 there. So why is this important, right? Well, it turns out like asynchronous workflows are really hard and they're really error prone, right? Throughout the context lifetime of a request at Netflix or in your application, you might make a whole bunch of asynchronous calls, some in parallel, some serially. And if a few of them fail, then you really need to know which ones failed to be able to actually debug your application, right? So I might, in the context of a request, make some API calls, at the same time persist some state to the file system, and then I might query a database, and after I get stats back from the database, then I might update some caches locally, right? So this is really hard, because what if one of these guys times out or something? Something that I've had in production is I've updated my Node.js Postgres driver. I go ahead and make a query, and that callback never gets invoked, right? So then what happens? Well, if I don't have observability, my request just hangs there and just sits there forever waiting, right? And I've leaked a bunch of database handles, all kinds of stuff. So here's a good example. I hope you guys can see that, but this is sort of, I have function 3 there, and I don't return a callback, right? Can everybody see that? And so my results object looks like, hey, function 1 is completed, 2 is completed, and my third function is pending. And this is really, really useful because now I know exactly where I'm stuck in my pipelines, right? So I no longer have to guess and figure out where things are stuck. So this is all great, right? But how do I see this in prod, right? Am I going to be, one thing we could do is dump these results to the logs, which is the example that I've given. There are some other things you can do because you might not want to be dumping all this stuff in logs all the time. That's kind of untenable, right? So you can take a core dump of your Node.js application, and that's while it's running. So it's not that intrusive. It comes with GDB, so you can go grab that. And then that later on, you can inspect that heap object for all the JavaScript objects on a heap, and find your results object and see where you're stuck. So that's pretty helpful. You can write a REPL into your application itself, and then go query all the results objects you want there. Also, you can make an HTTP API available too. Right? It's just different forms of Elastic, just different forms of IPC. So we find this is really useful. So moving on, let's talk about the second module that we use quite heavily. Anyone heard of this one, Bunyan? Yeah. Fantastic. So all Bunyan is a streaming JSON logging library for JavaScript. And it works on the server with Node.js, also works in the client with Observable. It's fantastic. So streaming JSON, who knows what that is? Everybody? Fantastic. So just a quick refresher. Streaming JSON is basically a format where you have a fully qualified JSON object on every line, and so each object is delimited by a /n. And a great example of this is Twitter streaming API, right? All your tweets get encapsulated in a JSON object, and they get streamed to you. So why is this great? Why is this powerful? Well, it's great for machine processing, right? I can query all the JSON fields and use standard Unix tools because they're all text-based and they're expecting something with new lines, sort of the Unix philosophy, right? I can go in and using the machine, go and figure out, hey, show me all the requests that return a 200 or something, right? I can do all kinds of different queries. The sort of drawback is that you can't really read it as a human, right? These are actual production logs, right? I don't actually live in the matrix. I can't read the code that easily, and this is scrolling by. I can't find the girl in red. Sorry, guys. So, luckily though, there's a button CLI that gets shipped with the Node module, and it's really, really powerful. I'm only showing you the prettified way that it transforms the logs. So here you can see I took those same logs, but now they have different, because they have different levels, those get different colors. I get dates and times, and I get all my objects printed out. It's got some other really great features, which I'll talk about in a little bit. So here's some features of the Bunyan framework, right? It's got 6 logging levels. It's got extensible streams interface. You can render custom objects with custom serializers, and it's got DTrace support. So the easiest way for me to actually show you some of this stuff is via demo. So I'm just gonna step over here. Let's see how good I am typing with one hand. So here's a pretty typical hello world example. Right? I record the Bunyan module in, I gave it a name, and I tell it the level at which to log at. Thank you very much. So if I were to run this, thanks. If I were to run this, you see that I get some streaming JSON logs out, right? Or just one entry, which is, I'm just gonna format it. And then if I pass it to the Bunyan CLI, ta-da, it's all pretty, yay, right? It's fantastic. So, I don't know about you guys, but when I was first starting in Node in the 0.4 days, all the logging frameworks didn't emit line numbers. So when I was debugging, it was really a big pain because I didn't know where my logs were coming from. So here's a great feature. I can add the source :true flag up here, right here. And so now, my logs have line numbers. Hooray, right? Here's a sort of a quick look into the API. So I mean, that was kind of useful, but not really, right? In the real world, we actually log objects, like a request and HTTP request and response objects. And so Bunyan fully supports the printf convention, so I can log everything as a string and pass in different parameters. And so that looks like this. So you notice that I get let me show the raw format actually. But I get everything logged as a string, right? My message there is one string. This isn't very useful because if I'm machine processing these logs, I really don't want to have to parse strings or properties, right? So the thing that I can do is instead, Bunyan offers this API where you pass it as the first object a JavaScript object, and you can pass in as many objects into there as you want, and they get first passed into the streaming JSON object. So now, if I run it, it looks like the second JSON object, you see that the request and response are actually fully formed objects. So now when I'm graphing through these lines with a JSON parser or something, I can easily get all the requests that have a status color and a latency of a certain number, right? I'll just show you quickly what that looks like for humans. It's basically like that. Great, so, right. So recall I talked about serializers. Serializers are really powerful. Here's a great example. I've got some auth info down here, right? And it's got my name and my password. I'm getting it done, I'm authenticating this request. I don't want to dump the password to the logs. So what I can do is use the serializer interface up here, and I specify the name of the object I'm passing in this case is auth.info, and then the function gives me a handle to the actual object. And with that object, I can transform it to whatever I want. So I can add state, I can delete state, I can mark out my password here, right? So if I were to run this without the serializer, it'll look like this. So it logs on my password. That's fantastic, right? I'm sure all those companies that leak passwords maybe leak it like this. So if I bring up the serializer back, it looks on my password, right? So you can use this for, this is just one example, but you can use it everywhere. So there's one more example, which is with errors. So we had a lot of problems before when we had errors and we would never get the stack trace, so we'd have to do like error.get stack trace, right? Button provides you with a bunch of standard serializers that you can use, including the error one. And so here I'm just reading a file from this that doesn't exist, and I log out the error when it comes back. And so hooray, I got a stack trace, right? So thanks. Let's go back to the slides. So the last feature I want to talk about that Bunny uses is something called dtrace. Is anyone familiar with dtrace? Heard of it? Cool. So dtrace, explaining dtrace is way out of the scope of myself and this talk, but if you're totally interested, go check it out. So dtrace is a dynamic tracing framework. You might not have heard of it because it was originally developed on Solaris, but it's now been ported to BSD and critically all those MacBooks sitting on your tables. You can man dtrace right now and run it. And that's great for us because we run our development on Macs, so we get that in our dev environment. So think of dtrace as like a runtime debugger. There are these things called probes that you can switch on and off electively inside your code. And dtrace just works with any sort of native applications. So anything written in C or C++, it just works. For higher level languages, you need something called a provider. And there's one that's already been out there for a very long time. It's very mature. And that lets you write dtrace probes in pure JavaScript. So you're not doing anything C, you're not doing any OS programming or anything like that. And where this is helpful is with a feature in Bunny called Bunny-P. I'm going to demo it in a second, but I'm just going to explain quickly what that does. So imagine you're running some code and you're logging at like an info level or something, right? And you've hit some pathology, right? And like if you go, and now you want to see additional state about your application, or you want to see like your trace logs, right? Because before they were too verbose, but now you actually need them. If you go and bounce the process, maybe that state goes away and you can't repro it. So what you really don't want to do is bounce the process. You want to leave the process up and running, but still inspect your logs at a different level. That's what Bunny does, and it does it via dtrace. So let me show you quickly what that does, how that works. Oh, it's right there. Fantastic. So here's my random application, right? And I've got, it's my hello world, except I'm logging something every second at the trace level here. So if I were to just run this, right, I get my info, but the trace log never fires because it's a trace. And now I've hit some pathology and I want to see my trace logs. All I have to do is find my nopid, which is this guy here. And then I can do Bunny-P, pass it the PID, enter my password. And you see over here on this separate process, those trace logs show up. So this seems kind of magic. I'm going to explain at like a really high level how this works. So what happens is when you enable a dtrace probe, it actually patches into the kernel and writes into a buffer whatever you want. So recall I talked about how Bunyan has extensible streams. So with Bunyan, you can actually send your logs to any stream compatible interface. So that could be a TCP socket, that could be another process, it could be a Unix domain socket, whatever you want, anything that supports streams, right? So what it's doing here is we've enabled dtrace over here on the second process, and that flips the bit through dtrace in the original process and says, hey, when this probe fires, I want you to send all the logs to the in-kernel dtrace buffer. So then we're streaming that to the in-kernel dtrace buffer, and then over here on the second process, we're sampling that buffer every I think it's like a 1 hertz or something, and we're sampling that and we're grabbing that out of the buffer and then dumping it onto the separate process. So I'm not changing my original process at all, I'm not doing anything, but I'm able to get my trace logs in this other way on a different process. So this is just sort of the tip of how dtrace works, but this is really helpful in my development environment, right? But unfortunately, it doesn't work in prod because we run Linux, and we run Linux Ubuntu on EC2. So we've got a fully fledged performance team at Netflix, and so we've been actually talking about some future work where we can get probe access in Linux. And so we're banding around some ideas like System Tap or the Linux tracing toolkit NextGen. We've even floated a patch for perf events so that we can get probes into Linux as well, so we can get that amazing functionality. So stay tuned on that. All right, so the third and final framework I want to talk about is Restify. I should have said module, right, because we're all on modules here. Anyone use Restify? Sweet. So Restify is a production tested REST framework. We host a website on Restify, and we're going to be hosting all of our other devices as well. And it's got a ton of REST and HTTP features. I'm not going to talk about those today. I'm here to tell you about the reason we chose it, which is its observability and its metrics. It's also got really great first-class bunion integration. This means that any log that you emit from Restify within the framework, your logs are streaming JSON, which is incredibly powerful, as I'll show in a second. And also, it's got D-trace support as well. All right, so here's what a vanilla app looks like. For those of you that have worked with other frameworks, this should look pretty similar. Right? I specify a route, and I give it a set of function handlers to handle that route. In this case, I've just got one, which is hello, and it sends back my name that I pass to it. And so when I run it, hello, right? Not very interesting, but let's move on to the interesting bits of Restify. So what is really interesting is the metrics that it gives you through logging. So who here has had this problem where they've had a bug in production, they log onto the servers, and they can see where the error is actually happening in the logs, but they don't get all the context because you're logging an info and not like trace. Has anyone hit that before? Right? That's one of the biggest trade-offs when you're running production services, right? I think Facebook also had a blog post about this where we get so many requests that it's untenable for us to log everything all the time, because then you spend all your time on all your I/O and all your CPU utilization writing logs to disk instead of serving customers. And so there's always that trade-off, right? Well, what if I actually need all this information? So Restify has this really cool feature where it's something called a request capture stream. And what it does is it captures all of your logging records at all the levels inside a ring buffer in memory, right? And so in a happy case, I'm chugging along, I'm turning 200s, I'm only logging at the info level. But what happens when I get an error? When I get an error, then Restify will go into memory, grab all the logs that are pertinent to that request, and then dump them to disk. So that is really helpful. When I hit an error, that's when I want to know all of my context, and I get that with this feature. Right? So the second really nice feature with Restify is something called auto logs. And this you get for free as well, and they look like this. This is a little bit scaled down. I'm going to show you some of the details in the next slide, but it gives you almost everything you want as part of a request. Think of it as like a summary for your HTTP request. So for example, I'm getting the URL and the HTTP method and the HTTP version. I'm getting the status code. I'm getting a request ID that's generated for this request. Crucially, I'm getting request latency, which is, as we all know, really, really important. This is actually a production auto log. I don't know if you guys can see, but the latency up there is in milliseconds, and it's 7,000. That's pretty terrible, right? It's like, why did I use this slide? I should have used one that had like 200 milliseconds, because we're always that awesome. We've also got the request headers and the response headers. Some of them are redacted, obviously, but that's really helpful. And what's really helpful down here are the individual handler timers. So most requests or APIs where you have this long chain of handlers. And so the reason I picked this really bad request that took 7 seconds is that if I didn't have these handlers, all I know is that my request took 7 seconds. I don't know where they took the 7 seconds, I just know they took 7 seconds. With the individual handler timers up here, I can actually see there are 2 outliers right there, right? One that's called render, so maybe I need to go fix my rendering pipeline or change it, use React or something instead of whatever else I'm using. And the other one is when we're going to API to get data. So this immediately makes it really clear to me where I'm spending all my time in my request, right? And this makes it easier for me, way easier for me to scale because I just know what things I need to work on. For example, I know I don't have to work on X-frame. That took 36 microseconds, right? Don't care about that. Another feature that's really nice is something called scoped child loggers. And what that is anytime you're logging within the context of a specific request, remember that UID I talked about in the auto log, that gets decorated onto all of those logs as well. So this makes it really easy down the road when I'm grepping through my logs. I just have to look for that UID, and that gives me all the logs for that specific request. That makes it really, really easy to track down problems specific to a request. So we send the request ID back as a header, right? So when we get calls and say, hey, this particular request failed, we can log onto the instance and quickly get all the context for that request. So just to summarize, we've got native binding integration, we've got that request capture stream, we've got the auto logs, and we've got scope child logger with each request. Does anyone want to see a demo?
Yes. Sure.
All right. Thank you. So let's look at the auto loggers. Actually, I'm just going to show you the main one because it's kind of a pain in the butt right now to do. Right. So here's my request capture stream example. Okay. So I've got my logger up here. Here's my server. I pass it an instance of a bundle logger. And here I've got my request capture stream, which I'm configuring it. So I'm saying, I want you to capture all log levels, debug or above, and store them in memory. When you see a log level that's greater than 1, I want you to dump all the context out. And you can configure it with the number of requests and request IDs that you want in case you're strapped from memory or something, right? So when I run this, it looks like this. Oh, hold on a second. Let me show you what the API looks like. So here's my hello API, somewhat expanded. I've got an authentication function now, and here's my authenticated blob. Let's say it's a cookie or something. It's really, really large, or an HMAC, right? So I'm logging into the debug level, right? So I don't want to see it in prod, and then 50% of the time this is going to fail because authentication failed or whatever, right? So now we're going to run it. Started. So, well, we hit the 50% case. There's no problem. Excuse me, there's no problems. Oops. Do it again. No problems. Man, statistics. There we go. Okay. So, here we see this request failed, right? And then I've actually dumped out the debug object for that request, right? Even though, and here's my warm log. So I've dumped out the debug log. So that's really, really helpful. We get this all the time when we're dumping like customer context. And we can't dump that because they're huge, right? But we dump it on error, which is really helpful. So that's the request capture stream. Let me show you what the auto logger looks like. So the auto logger is just a plugin that you use. Restify gives you this after event. So it tells you that, hey, you get this event that fires after the request has been sent. And then you can just add the auto logger as a plugin to that. And so, right, so we still got the same failure scenario here. 50% of the time will fail, right? So this is great. So now we've got, oops, slide. So we've got the failure case here. So authentication failed, and so one thing I didn't mention with the slides is it also inlines the error with the stack trace for you as part of the auto log. So we see, hey, came from this remote address, blah, blah, blah. Here's my headers. And hey, my request failed, and here's actually the stack trace of where it occurred. And I'm still getting my handler timers down here. So that's a good auto log example. And then the last one is go request logger, so I named that. Child logger. So this just utilizes a plugin right here called request logger, right? So if you look up here, all of these guys didn't have a request ID associated with them. So if I was grepping for this request ID down here in prod, I wouldn't actually get all that information, right? Because it doesn't have it. So, but if I enable the scope logger, then when I run it, right? You see all my logs get decorated with our request ID. So now I can just literally prep for this because the raw records actually look like streaming JSON, right? So they're all in one line, and grep works perfect, and it's going to give you back all of the logging records for that particular request. All right. So the key takeaway here with Restify is Restify plus plugin, right? You're getting your streaming JSON logs, and that means processing using Unix tools is really easy. Sure, question?
One thing that you should add on to that list of Unix tools is there's a utility called JQ that is like awk or whatnot, but it's specifically for JSON.
Right, that's great. We should add that. I think JSON also does something similar, but I would love to check out JQ. I use JSON all the time. I haven't discovered JQ yet, but JSON is fantastic as well. You can strip out fields. You can do like equality checks. Also, Bunyan, there's a -c command, and then you can run JavaScript on your logs, right? So you can do this, which refers to the object. I'll show a demo of this later, but this, which refers to the object, and you can do equality checks and parse all things. But going back, processing using any Unix tool is easy, right? This makes it really easy to look for things. One thing I really like is dagger, which gives you which lets you do distributions. It's really hard to do distributions, so it turns out I don't know how to use R. I've tried, but I'm not mathy enough. But dagger makes it really easy. So here's some examples that you could do. You could find all the logs for a specific request. That's just doing a grep, right? You can count the number of non-200 responses in a particular log. You can show all the requests that took longer than 1200 milliseconds because we have all of this data in the logs. And here's more of an advanced example. So what I'm showing here is I'm taking one single log and I'm getting a distribution of the request latencies, and I'm sorting them by the URL. And this is actually really, really long. I've only showed the first two. But the first one is viewing activity, so that's your viewing activity page. And we can see that most of the requests took around less than 512 milliseconds, which is pretty good, actually. Our search page is a lot similar, so I've got distributions down here, right? So this is really, really handy, because sometimes it's not good enough to just look at your top worst request or your top best request. You really want a distribution, because it could be bimodal, right? You could have a bunch of requests that take 2 seconds and a bunch of requests that take 32 milliseconds, right? And you really want to get that information to a distribution. So you can do this with logs. Right, so I'm going to talk a little bit about Restify's dtrace integration. And so here are all the dtrace probes that it provides. Of note are the route and handler ones. So this gives you timing information as well. So we did timing information through the logs, but you can also get them through dtrace. So if you're running this on your Mac or something, and you don't want to parse the logs, you can just run a dtrace command, and that'll give you distributions of your request latencies. So this is much easier to show with a demo. So here's my vanilla sort of Restify server. It's got all this stuff set up. And I've artificially introduced some delay here in the hello handler. So 50% of the time, it's going to take a second to return here. I've got the set timeout, that takes a second. So we would expect to see a bimodal distribution, right? And I think this is actually one of the coolest features, to be honest. It geeks me out. So I run this. All right, so my app is running. Okay, so I'm gonna hit the server with a bunch of requests. Say, hopefully I have this cached. There we go. All right, fantastic. So hit the server with a bunch of requests. You can see stuff is scrolling by, right? And then I can run my dtrace script here. And what this is going to capture is it's going to capture all the start and stop handlers and the start and stop routes, and then print them out in a distribution for me. So if I want to run my dtrace script, all right, so now I'm running, And it's not going to show me anything until I get out of it. Right now, it's just collating all the data. So we let it run for a few hundred requests. Come on, 400 requests. Come on. Whatever, it's good enough. Whatever it is. You see, now I'm going to actually look at this guy. You guys can see this better. Right? We see what we expect, right? So authenticate took no time at all because it's basically a no-op. Same with Bunyan and same with the parse query string. So we have a query string parser that's a plugin. That's basically just a handler that gets prefixed to the chain. So we actually see that timing provision here. Here's my hello handler, right? So we see what we expect to see, which is half the request took about a second, the other half took no time at all. And then I also get timer for the entire API, which again, we would expect to see that's very similar to the hello handler because that's what we're spending all the time. So that is a quick demo of how dtrace works with RESTify. Great. So to sum it all up, this is sort of like a diagram of all the metrics that you can get out of RESTify and sort of the ways to get at them. Right? So I've got my auto logs up there, and that's got a whole bunch of context information about my request, which we find really, really helpful. Then I can take those requests, and if I'm on the box itself, I can use all the Unix tools that are available and look through them and find whatever it is I need to find. Get distributions, look for bad requests, look for outliers, right? And then we've got request scope logs, which dumps application-specific logic that I can easily find as well. And I've got the request capture stream, which gives me all the context that I need whenever there's an error, which is critically important, right? So all of those gets rolled up in my logs. But then we're actually in the process of dumping all of these logs internally to Elasticsearch, and then we can query all of them across our entire cluster and really get great distributions. But you can do that yourself as well. You can send it to some sort of distributed processing framework, right? Whatever you like to use. And then along to the side that's not related to logs is dtrace support, where it's available, which is currently on macOS 10 and BSD, but we hope at some point we'll be able to get probes in Linux, and that's going to be fantastic. So that's a brief summary of RESTify. So back to these graphs, right? Remember these? So with everything I've showed you today, hopefully you've learned something where we've got enough metrics now where, hey, I can easily go look for, where are these error codes? Let's say they're 500s or 404s or whatever. I can go through my logs and get context on those and fix the problem, right? With this increased latency, right, you guys will remember Node.js in Flames. With this, if we had the handler timer back when we had this problem, that would expose it right away, because what was actually happening is we would refresh all our API periodically, and we had a bug where we would add an extra handler to the end of the chain every time we refreshed, and it was additive. And so we would have saw that right away with the auto logs, because we would have seen like, hey, you've got all these static handlers that keep on getting bigger and bigger and bigger. So, this gives you a good sort of overview of how everything works and how you can actually use it in production. So if you're interested in RESTify, check it out. Right there, restify.js.com. We're actually also looking for contributors, so if you feel like contributing, pull requests are always welcome. And so, just to sum up, here's the Kiro combo. We've got vAsync, which gives you observability over maybe the hardest part in JavaScript, which is asynchronous operations. We've got Bunyan, which gives you streaming JSON logs, and now you can parse them with machines, because machines do it much easier. You've got RESTify, which gives you all the metrics that you need as part of building out a REST application. And then finally, a shout out to the Unix philosophy, right? Streaming of text model. So you've got many tools there to manipulate your JSON logs. And finally, just leave you with another picture of community data, this time as Sherlock Holmes. Don't forget, even if you don't use these frameworks, don't forget that core tenet, which is get the data first before you go on and try to figure out what's wrong with the application. So thanks. I'll take questions if you have any.
There's really no all right, good.
How far along is the Linux port dtrace?
Well, so to be clear, we're not going to be using dtrace in Linux. Linux actually, so dtrace works really, really well for this kind of stuff. It does it a little bit inelegantly because you're trapping into the kernel, and you're setting buffers in the kernel, but this is between two user space processes, so you don't actually need to do that, right? So Brendan Gregg, who's you guys probably some of you heard of Brendan Gregg, is one of the sort of performance architects at Netflix. Him and I have been talking a lot about how we can get the same sort of probing functionality into Linux. Because as you guys all see, this will be fantastic, right, to have. But so those 3 frameworks that I talked about, those are really good potential candidates. I think LTTNG is actually getting incorporated into the kernel soon, which is great news, because once that's there, then Linux generally doesn't let crappy things into the kernel, right? So we all know. So that's a great framework.
Good things too.
What's that?
Good things too.
Good things too. Yeah, we could go all night actually about that. But yeah, so those 3 frameworks are sort of perf events. Actually, is something that we use all the time to generate flame graphs. For those of you who are not familiar with flame graphs, it's basically CPU profiling, so you can see where you're spending your time in CPUs. But perf events is also really it's part of the kernel as well. So those are solid frameworks. We hope it's something that we really want to get there. It's more just we have to engage with the community and the Linux folks to figure out what the right solution is. I saw some of the hands back there.
So you spoke about like VAC, and so what's your thoughts about like Q module? I know you could use like promises. I know like JavaScript community is more.
Right. So promises is this really elegant way of handling asynchronous operations, right? And your code is really, really nice, right? And like it makes sense to most people. I want to show you something actually. The reason we don't use promises is because they kind of muck with the stack traces a lot. And so we often sample the CPU and to see where we're spending all our time. And the problem with promises is everything derives from a promise then. And so it's really hard for you to see where you're spending all your time on CPU. And I'll show you with an example. So here's a flame graph. It's kind of zoomed out, but for those of you who are not familiar, there's no timing or anything like this. So the width is on the x-axis. It's how much time you're spent on CPU, right? So the different colors are. So the red is libc, the yellow is like V8, and then anything green is your application level code. So here. See this promises right here? This is when we're still using promises. The problem with this, and if you move down here, yeah, see this is promises as well. The problem with this is everywhere in the stack trace at the same spots. So it's hard for me to see like where we're spending all our time because all the discrete chunks of code that end up looking like this up here. So I can zoom in here, but it all ends up looking like this, right? And these are all part of the promise chain. And it, for the lack of a better word, kind of like poops all over your stack traces. And so it's really hard for you to see what's going on. That's the main reason we don't use promises. I admit it's really, really elegant, right? And so the problem is that with most implementations, it doesn't play nicely with your stack trace. And so I can't see really where I'm spending all my time on CPU. I know it's somewhere in here, but it's all sort of discombobulated. No problem.
So, a generic question about dev and production systems.
Yeah.
So, from my prior life, I know it's very hard to mimic a production system from the dev environment, but every production system has some flavor that the customer triggers and you see that pattern and you try to mimic it during your testing.
Yeah.
You have most of the data from the user in, say, the West Coast or somewhere when they log in and do those kind of things. Why can't you replay all of that to mimic a production system?
We could totally do that. The problem is that I've got hundreds of thousands of instances and they're load balanced, right? And generally it's not one request that causes the pathology. It's like a series of unfortunate events. It's kind of like cancer, right? I have to get this entire chain of unfortunate events for me to hit a memory leak, or for me to get stuck, or whatever, or it could be a timing issue. A lot of these bugs are sort of race conditions. So replaying the request might not get me what I want. What I would suggest you guys go check out is core dumps. So when my process is hung on Linux, I can actually take a live core dump of my process, and then using this tool called MDB, which is available on Solaris, but it reads Linux cores. That's what's important, is it reads cores, Node.js Linux cores. Excuse me. And then you can actually look at all the native JavaScript objects. So I can actually see all of them. So I left out the memory leak problem, right? I don't know, astute viewers may have noticed that there was only 2 graphs at the end. the memory leak, I don't know if I have enough time or not, but the memory leak problem we actually solved by looking at the heap data, right? Because then we were able to see that, hey, we were leaking like 100,000 React elements, and obviously that's what we were leaking, and we were able to trace back, when we take deltas of the heap, that there was like a global array that was holding on to all of these things, right? So that's what I would suggest doing. If you don't get enough context from your logs, you could always take a snapshot of the process and then dig through that later, right?
So you said you log into a disk and then you're planning to read from disk and then put it in Elasticsearch. Why don't you just put it on database from the first place?
Oh, I'm sorry. So actually, the way we're thinking of setting this up is we're going to remember that they're streaming, right? So we're streaming logs to disk, and those get rotated to S3, right? And so what we could do is take the logs from S3 and put them into Elasticsearch, but rotation only happens like every couple of hours. That's a slow process. So what we got at Netflix is the data pipeline team, and so I'm writing this Kafka plugin for Bunyan, so that we can stream the logs over to Kafka, which then will stream it into Elasticsearch for us. So that's how it's actually going to work. So it's never going to hit the disk at all. Any other questions? Back there?
So when you actually use the Bunyan logs, I mean the terminal to actually close, because you said like you're gonna send it to like a database like Elasticsearch.
Right. So you can use. Let me actually just show you then real quickly how you can do that.
What's like the actual use case?
So yeah. So like suppose I push out a new build or something, and suddenly I notice that my application is taking a lot longer. Maybe the same path or same URL is taking 3 seconds instead of 2, right? So what I can do is go onto one instance, dupe the logs, and get a distribution like I showed back here, right? And then it'll show me, hey, where am I spending all my time in, right? This is just one example where I'm doing every for different URLs. I can of course do this for just one URL, but do it for all the request handlers too, right? So this is where it becomes powerful because it's like an analytical framework, right, where I can go and look at and see where I'm spending all of my time in terms of my request handlers. So, of course, you're just taking a sample on one machine, right? When we have the Elasticsearch or whatever distributed computing pipeline set up, then you can sample your entire network traffic, right? Everything that hits all your instances. Anyone else? All right. Well, thank you, everybody.